Hi all, you're watching Simulink tutorial and today we are going to see the Simulink function in stateflow, how to use it and when to use it. So let's start. So this is the requirement that I have written for this model. So there will be two inputs. The first input will be of 0 to 5 volts. So its value will be from 0 to 5, and the second input will be of 0 to 12 volts. So the value will be from 0 to 12, and there will be two outputs, so each representing the percentage of those inputs. Okay, so these are the three requirements for the behavior of the model. So the first one, it says initially output will be calculated from whatever input it is getting. So this is for the initialization, that is the first sample value. After that, when input is changing continuously, maintain the previous output, and if the input is steady for at least 500 milliseconds, calculate the percentage. So we'll see step by step how to fulfill all this requirement and complete the implementation using Simulink function block in stateflow. So there could be different ways to implement this, but I am using this implementation. So let's start. So for two inputs, I'll be using this signal builder block. So I have already modified this signals for testing purpose. So if you are new to signal builder, then I'll just show you how to add signal and modify it. So go to signal, select new, and then the type of signal that you want to use. So let's just select the pulse. Okay, so the signal 3 is added. You can modify its name from here. Okay, and to modify its values, let's say I want to modify this signal from 6 to 8, and I want its value to be 0.6. Okay, so what you have to do is select the signal and shift, then just click where you want this point. Okay, then select the section of the signal that you want to change. So I want to modify the values from 6 to 8. So just change this, select this one and give whatever value you want it to give. So I want this to be equal to 0.6. Okay, now you can see here that this signal, that is 6 to 8, what I'm taking, it's actually from t equal to 6 to 7.98. So I just want it to be exactly 6 to 8. So select its time sample, that is at 7.98, and change the t equal to 8, and you have the signal between 6 to 8. If you want it like a ramp, then just change the position of this point and so on. So that is how you can change the values of signal and add the signal to signal builder. Well, right now I don't want to use it, so I'll just delete this one. So right click and delete. Okay, so these are two signals, that is signal 1 and signal 2. I want to use them as input. Now let's take a block of data type conversion. So by default, the signal builder will provide you the signal of data type double. You can modify it. Let's say if you have signal of type boolean, then select it as boolean. I want the signal to be of data type single, so I'll just select single, apply. Okay, copy it, and same for signal 2. Now let's take a chart, as we want to implement this using the state flow state chart. Okay, now double click on this chart. Now what we have requirements, that is we want two inputs and two outputs. So to add input signals from Simulink and output signals to Simulink, click on the model explorer. Okay, click on add data. We'll just call signal 1 as in 1, scope input, then in 2, scope input, then output as %1, scope output, send to, and output. So that is how we can add inputs and output to chart. So we can see here input and output ports are added to this chart. Connect the input signals to chart. Now let's design the behavior of this model. So in this model, the main thing that we have to do repeatedly is to calculate percentage. And in software programming, when we have to perform same task repeatedly with different inputs, we define one common function for them and pass the arguments to the function. So in this model, the main thing that we have to do repeatedly is calculate percentage, but in actual application, this repeated task can be complex and it can involve a number of operations. To keep this model simple, I am using the percentage operation. So same thing we are doing here, that is we'll define one function and write its function body. So let's take a Simulink function. Okay, just expand this block. So what output this function will provide is percentage equal to the name of the function, that is cal percentage. Okay, in parenthesis inputs, that is input signal, and the maximum value of its range, as we have two different values, that is 5 and 12. So max val. So this is the output equal to function name in parenthesis the inputs for the function. Double click on this function block and you will see function caller, this output, and two input ports. So for percentage, it is a simple formula, that is value divided by maximum value and multiplied by 100. So type divide. So we'll use this block to calculate the percentage. So modify this operation. So multiply and divide. Okay. So input is in multiplication. Max value will divide the input, and to multiply by 100, take a constant block. Okay, of data type single, and as our input is of type single, we'll select the data type as single over here. If we do not explicitly define the data type over here, then at the time of simulation it throws error. So in Simulink function, never keep the data type of input ports as inherit auto. Give its data type explicitly. So single. Okay. Same applies for max value input. And connect this output of this divide block to the percentage value. Okay. And that is how we write the Simulink function body. We'll just have to add different blocks to perform the operation that we require. Okay, so now our function is ready. Now let's implement the remaining three requirements. So let's take a state, remove the default transition, as I am going to convert this state to a parallel state. So this first state will be used for the processing of the signal 1, and the second state will be used for the signal 2, as both need to be processed independently but parallelly. So give a name to the state. So signal 1 processing. Okay. Add a state inside this state. Just name this state as init. Now what our first requirement is, initially output will be calculated from whatever input it is getting. Okay, so at this default transition we'll call the function to calculate the percentage. So copy this and in curly braces paste it, semicolon. Now our first output is %1 equal to this function name. First input is in 1 and the max value for the signal 1 is 5. So we'll define this 5 as constant in Model Explorer. So go to Model Explorer, add data, 5, constant of data type single. As if you remember, we have given the data type of max value as single. Okay. Similarly, we'll add 12 for the second signal, constant data type single, initial value of 5 is 5, apply for 12, apply, close this window. Now we have fulfilled the first requirement, that is at initialization whatever will be the input will calculate the percentage of it. Now the second requirement is, if the input is changing continuously, maintain the previous output. So to detect the change in the signal, I am using the inbuilt function, that is has changed. So if the signal is changed, re-enter the init state. Okay. So if you search in documentation has changed, it will give you the results how to use it and other functions also, that is has changed from, has changed to. Okay, so I'll use the has changed. So has C capital changed in parenthesis input signal 1, that we want to check if it is changed or not. As this is a condition that we want to check, write it in square bracket. Okay, so if the signal changes continuously, it will re-enter the state. Since we haven't written anything inside the state, that is entry or during action, it will maintain the previous output. Now add another state. Let's call it as processing. Okay, add a transition from init to processing. So if the signal changes, re-enter this init state. Else, after 500 millisecond, go to this another state where we'll calculate the percentage of the input. So again, copy this entry, paste it, remove the curly braces as this is in state, and if in this state input changes, go back to init state. For that, the same condition will use, that is input has changed. So we have fulfilled all three requirements. Now click on this parallel state, right click and drag it. So there will be a second copy for signal 2 processing. All we have to do here is just rename the signals %2 input 2, here 12%2, here input 2, input 2, and now our model is ready. Add a scope to observe the output, connect the output to the scope, go to configuration parameter. I had already modified it, that is type fixed step and discrete, and fixed step size, that is sample time, as 100 milliseconds. Okay, save this model, double click on the scope, go to view, layout, select 2 row configuration, double click on the signal builder. So now we can observe input and output together. Okay, simulate. So at initialization, the value of both the signals is 0. So the percentage is 0 in both the cases. While the signal is changing continuously, the previous value, that is 0, is maintained. Then this second signal at 4 constant, if we zoom this signal at 4.5, the new percentage value is calculated. For signal 1, this constant signal is from 1.98, as we have sample time of 100 milliseconds. So this model will consider it from 2. So at 2.5 we should have the new percentage. So this is where we are getting the new value, that is exactly at 2.5. We fulfilled all this requirement, that is 2 inputs, 2 outputs. The percentage value, initially the output will be whatever the input we are getting, its percentage. Then if the signal is changing continuously, maintain previous output, and if input is steady for at least 500 milliseconds, calculate the new percentage. So what we learned today is how to use Simulink function and define it and write its function body. Then how to use parallel state. There is another video of mine explaining parallel state, so it is in detail. about parallel state. So if you want to watch that video, click on the link in the description below. So next time when you are designing a model and there is some repetitive operation that you want to perform on different signals, try using this Simulink function block if it fits in the boundary of the implementation that you want to do. So that's all for this video. If you like this video, give it a thumbs up and keep watching and keep learning.